In the third and fourth videos of chapter 48, we're going to talk about the shell method. And the shell method talks about, we have the same idea as we did with the washer method or the disk method. So we have this function that we're going to use to create a three-dimensional solid. Only instead of revolving this around the x-axis or another horizontal line, we're going to revolve this around the y-axis. So we're going to take this and we're going to revolve it around the y-axis. I tried to make a mirror image here, but as we spin this around the y-axis, not a great drawing, but I think you see the picture. And this creates a three-dimensional solid, and there's another formula for that. So we integrate 2 pi x f of x dx. That is a formula. This is called the shell method, and this is theorem 358, and this is our formula for when we have a three-dimensional solid that we're creating by revolving this region about the y-axis. And that's what we're doing in part C of example 359. And in part D, we're going to revolve it around another vertical line. But in this video, we'll look at part C. And so I left the picture up here. So we're taking this region, same region we have, and now we're going to revolve it around the y-axis. That'll make another three-dimensional solid. Now, I'm going to do this in two pieces. I didn't do just a one-function straightforward example of the shell method. So I'm going to present this as two one-function straightforward examples of the shell method. So first of all, we have the region that's bounded by the fourth root of x. We're going to revolve it around the y-axis. That's going to make a three-dimensional solid. According to our formula, the volume of that solid is 2 pi x times f of x. Notice we're not squaring this time. We just have 2 pi x f of x dx. We're making a second solid. So if we take the region bounded by the line and we revolve it about the y-axis, that makes a second three-dimensional solid. And the volume of that solid is 2 pi x 1/8 x dx. And so we subtract the two volumes, and that's going to give us the volume of the solid that we're interested in. And so we'll combine this. We have the integral 0 to 16 minus an integral 0 to 16, so we can write that as one integral. We can factor the 2 pi out of the integral. And so that's what we have done right here. I've got my upper limit of integration, 0 to 16. But that's the integral 0 to 16 of factor the 2 pi out. Each of these functions was multiplied with an x. So we factored an x out, but we can't factor that outside of the integral sign because we're integrating with respect to x. So we have x, then we have fourth root of x minus 1/8 of x. And so, again, the details are in your notes. So we distribute the x through here, and we'll just have an algebraic function, find an antiderivative, substitute 16, substitute 0, subtract. We have 1024 pi divided by 9.